Dear students, in this lecture I will be discussing cyclic codes. Okay, so let us understand what is a cyclic code, what are the types of cyclic codes, what are the advantages and applications in this particular lecture. So cyclic codes are basically linear block codes. A cyclic code is represented as n, k, where n is the number of bits in the code vector and k is the number of bits in the message sequence to be encoded. Now, when you look into the definition, a block code is said to be a cyclic code if every cyclic shift of the code vector results in another code vector that belongs to the same block code. This is a definition. Now, let us understand this definition with an example. Here, in this example, I have taken a 7, 4 cyclic code where n is equal to 7 and k is equal to 4. That indicates that k is equal to 4 is the number of message bits and n is equal to 7 is the number of bits in the code vector. Now, since the message bit is of 4 bits, I have taken here the 2 to the power 4 combinations of messages. You can see from here 0, 0, 0, 0 till 1, 1, 1, 1. I have a total of 16 message combinations. Now, for every message sequence, there will be a code vector sequence. Okay, so now this is a code A. So this is one code and this is another code. I have taken here two block codes. This is block code A and this is block code B. Now let us first understand the block code A, whether it is a cyclic code or not a cyclic code. Now, if I want to understand that, what I'll do, I'll just take randomly a sequence, randomly one code vector from this block code A. So maybe this one I'm choosing, and I'll write here, that is 0, 1, 0, 1, 1, 1 and a 0. This block code I have in this block code I have taken this particular code vector. Now, as the definition says here, if you give a cyclic shift to any of the code vector in any block code, this is a block code, this is a code vector, I have taken that, and if I give a cyclic shift to this, either a right cyclic shift or a left cyclic shift, if I give, so it will result in another code of the same length. So let us see that cyclic shift, how I am giving. I am just shifting this bit to here. So that means that 0 comes here and this 0 comes here. This 1 will come here. This 0 will be here. This 1 will shift to here. This 1 will shift to here and this 1 will shift to here. Now, after giving a right cyclic shift to the selected code vector, I received a code vector. So this code vector, I have to check whether it is existing in this block code A. So let us verify that. So I have a 00, 10, 111. Do I have that? So I have here 00, 10, 111. So if you can observe here, this code vector exists in the same block code. If you want, you can take one more example here. Let me just take another example. I'll randomly choose this sequence now. 1 0 0 110, 1 0 0 110. Now let us do in this time I'll be giving a left cyclic shift just to confirm whether the right cyclic shift or left cyclic shift. So I'm just taking a left cyclic shift here. So when I do that, what exactly will happen? So this bit will be shifted to here. This is 1, right? And these bits will be shifted to the right. So this bit will come here, this bit will come here, this bit will be here, and this 1 will be here, this 1 will be here, and this 0 will be here. Now if I just look into this code vector, let us check whether this code vector exists in this particular block code here. So 0 0 0 1101, 0 0 1101. Yes, it exists here. So that confirms us the given block code A is a cyclic code. So the same thing holds good for any code vector here. If you choose any code vector and if you give either a right cyclic shift or a left cyclic shift, the resultant code vector, that whatever that you get, so it also exists in this block code. It will be one of the code vector in the given block code. Then I can say it is a cyclic code. Now let us verify whether the code B, the block code B, is a cyclic code or not. Okay, so to do that, again we will repeat the same process. Now I'll choose any one code vector randomly in this block code B. So I will select here. So this code I'll select 0011 0011 010. Now I'll give a right cyclic shift to this. So when I give a right cyclic shift here, so this bit will come to the first position, that is 0, and this bit will be here. Okay, all these bits will be shifted. So I can write it as 0 1 1 0 1. Sorry. So it is 0 0 1 1 0 1. So now let us check whether this exists in this particular code B. So 000 1101. Yes, it exists here. That confirms as if I give a shift to any of the block code vector, so the resultant code vector will always be part of this same block code. Then I can tell the corresponding block code is a cyclic code. Here code A is also cyclic code, code B is also cyclic code. So that is how we can confirm the cyclic codes. Now moving ahead, the types of cyclic codes. So we have here the two types of cyclic codes. One is a systematic cyclic code and the other one is a non-systematic cyclic code. What is a systematic cyclic code? If I just observe the code A, I can see here the first 4 bits of this code vectors everywhere. Carefully observe this. So if you just observe the first 4 bits of the code vector in code A is exactly same as that of the message sequence. Here 4 zeros are there, 4 zeros are there. Here 0001 is there, 0001 is there. Okay, so this clearly confirms that the first 4 bits in this particular code vector is going to be the message, and the remaining 3 bits will act as a redundancy, which is used for error correction and detection. Okay, so that is where actually we have a systematic representation here. The first 4 bits as always the message, and the next 3 bits as always the redundancy. That is a systematic way. So we call code A as a systematic cyclic code. Whereas the code B also, we have verified it as a cyclic code, but it is a non-systematic cyclic code, because here we cannot distinguish between the message sequence and the redundant sequence. Okay, so there is a major difference between a systematic cyclic code and a non-systematic cyclic code. See, observe here. So you cannot differentiate the message and the code vectors. 1010 001 is there. Here 0001 is there. We cannot make out which is a message, which is a redundancy. But here it is very clear. So the first 4 bits of all these code vectors are message, and the remaining 3 bits are redundancy. But here it is all jumbled. So that is the reason we call it as a non-systematic cyclic code. Okay, so now let us move on to the examples of cyclic codes. There are lots of examples in the cyclic codes. One such is Bose Chaudhary and Hakangem, that is also known as BCH code. We can also have some code called Hamming code, Golay codes, Reed-Solomon codes, or sometimes people will write it as RS codes. Okay, but one thing is here it is not a binary code, it is a non-binary code. RS or Reed-Solomon code is not a binary code. Okay, so when it comes to the advantages of cyclic codes, the implementation of encoding and syndrome circuit is very simple here, because it requires only shift registers and the adders. Okay, so it's a very simple circuit that we can build here, so the complexity is very less. And when it comes to the second advantage, cyclic codes have a fair amount of algebraic structure that makes it possible to use them as error correcting codes. This is one of the advantage of cyclic code. Now when it comes to the applications, mainly it is used for error detection and correction purposes. Okay, so that's all for today, and in the next lecture I'll be talking more on how to generate this systematic cyclic code and non-systematic cyclic code. Okay, so with examples we will discuss that. Till then, take care and thanks for watching this video.